Today we will be discussing about the yarn testing and the importance of the different yarns, the structure, their characteristics, and how we have to measure the fineness of the yarns, and how the twist and the crimp that is present in the yarns can also be tested, apart from what is the importance of all these elements in a yarn. In order to make a fabric, generally the first step is making the fibers into a yarn. So, this yarn has to be made in such a way that it can be used either for knitting, for weaving, or for any other purposes, and also there are different types of fabrics available, ranging from a very lightweight to apparel fabrics to even a very carpet fabrics and even industrial fabrics that are available. So, when we take the definition of a yarn, it is a generic term that is used for a continuous strand of textile fiber, filament, or a material that is suitable for knitting, weaving to form a textile fabric. So, in this we see that there are different types of yarns available or that can be produced either by the mechanical method or the chemical method. So, generally a yarn contains different forms, like the fibers being twisted together, or the filaments can be laid together, sometimes with little twist or without no twist, and sometimes we use a single monofilament, for example the silk. When we try to classify the different types of yarns based on their length, we can classify them as the spun yarns and the filament yarns. So, basically the spun yarns are the yarns that are made from the short fibers. The fibers can be either from the natural source or from the man-made source. The fibers are cut down to the length of the staple and then they are spun on the staple system. And coming to the filament yarns, these are supposed to be the continuous yarns that either can be reeled in case it is a silk, because silk yarn is reeled from a cocoon, or sometimes if it is completely thermoplastic, then it can be extruded from the spinneret. So, apart from that, we also have the natural filaments that are made, that is the regenerated cellulosic fibers that can also be made into a filament form. So, when we take generally the characteristics of spun yarns, we can see that they are mechanically assembled, that is the fibers are mechanically assembled and twist is imparted to them, and it does not mean that they contain only one type of a fiber, it can be a blend of different types of fibers. And in fact, there are different methods of making a staple yarn, ranging from the ring spinning, rotor spinning, air jet spinning, etc. And so, all these methods would produce the spun yarns only. But the method of spinning, the type of machinery that is used would definitely give a different property, such as generally there would be a lot of change in the uniformity and the strength of the fiber based on the type of the machine that is being used. And generally all the short fibers have the protruding ends on their surface because they are very short, and because of this they have a problem of pilling, and they also shed lint, but they have a very good cover factor. That means a small amount of yarn would be sufficient to cover a large amount of space, but they have a problem where they get soiled readily, but they are also warm, and above all they are also absorbent. That is the reason why staple fibers are mostly used in garments for summer wear for the as an apparel fabric. Now, coming to the filament yarns, as I told you, these are either naturally extruded fibers or sometimes we have the manufactured fibers. In this we have two varieties, the monofilament, which is a single filament, but it will be a thicker yarn, and we have the multi-filament where these yarns are the single filaments are placed together with either little twist or sometimes without no twist. No twist is generally given to these yarns to hold them together, and they are used as a single yarn during the weaving process. Now, when we talk about the yarn structure, we should understand the two aspects here. One is the yarn density and other is the bulk integrity. Now, as we know, the fiber is supposed to be the main component that is present in a yarn. Apart from that, we also see that there is air that is also incorporated during the structuring or during the manufacturing process of the yarn. So, this we call it as a packing fraction, which indicates the amount of space that is enclosed by the fibers. So, if we say for example, it is a 0.5 packing fraction, that means that we can see that the amount of air present in this would be equal to that of the amount of the fiber that is present in it. The major factors would influence here based on the structure of the yarn, because the packing fraction, if it is very high, then sometimes it leads to a very stiffer fabric, and in fact the strength would come down. And at the same time, if the packing fraction is very low, then there would be no integrity to hold the fibers together in the formation of the yarn structure. Now, when, as I told you that yarn density has a lot of influence on the fabric properties, it influences the dimensional stability, the strength, the elasticity, the flexibility, the fabric cover, absorbency and air permeability also. Generally, staple yarns and textured yarns will have low density than the continuous types of the fibers. And as I discussed earlier about the different types of spinning methods, so all these spinning methods would impact on the compactness and the density. The more number of fibers in a square inch would lead to a higher density. So, ring spun yarns for that sake would be having a higher density of compactness even than the rotor spun yarns. The next character in the yarn would be the yarn bulk integrity. It is nothing but the fiber arrangement in the yarn structure. Even here the type of spinning would influence about the bulk integrity or the fiber arrangement. So, these yarns would give, either you can make a yarn in such a way they are lively enough, and they would also influence the dimensional stability, the yarn appearance, the yarn strength and the fabric cover. Then let us see about the yarn count. So, yarn count is the fineness, that is whether the yarn is thin or thick. This describes about the yarn count. It is also called as yarn number, or sometimes it is also called as yarn size. Now, when we see, textiles are generally sold on the basis of weight. So, to express the size we say the thickness. Thickness in terms of weight is nothing but the yarn count. So, this numerical expression is to be given in two basic ways, and the first one is we call it as indirect yarn number and the direct yarn number, where one is length based on the unit weight and the next one is the weight based on the unit length. And it does not mean they are unique by themselves, because there is every chance to convert from one type of expression to the other expression. By definition, when we take the count, so it is the number which indicates the mass per unit length or length per unit mass of yarn, and the indirect count, the number of length in one weight unit is supposed to be considered as the count, and here higher the number, the finer will be the yarn. So, for cotton, worsted, linen and wet spun yarns especially, we use this indirect method of counting. The indirect count can be calculated by taking the unit weight of the system into the length of the sample by the weight of the sample into the unit length. So, this gives the count of the yarn. Now, as I told you, there is English system and metric system and Worcester system also, which can be expressed in the indirect system. So, under English system, it is a hank of 840 yards per pound, and it is generally denoted by NE. That means, if 840 yards of cotton yarn weighs 1 pound, then it is 1 count. So, as I told earlier that the higher the number, the finer would be the yarn. So, by multiplying, if suppose the yarn has a count of 10, that means 10 into 840 yards would be the finer yarn than compared to 800 yards per 1 pound. So, even in the English count system also, the length into pounds by the standard unit into the weight of the yarn, you can get the count of the system. In metric system, it is about the length is supposed to be taken in kilometer and the mass is in kg. So, 1000 meters per kg would give the metric system. So, replacing in the formula this yarn hank size and hank length, you can get the formula. And for woolen yarn, there are two indirect systems, the woolen system and the worsted system. Again, in the woolen system, we have two more varieties, where one is a unit length of 300 yards for 1 pound and the other one is 100 yards in 1 pound. In the worsted system, it is 560 yards that we consider to 1 pound, that we call it as a count. So, the same formula is applied here also. In place of the yards or the length, it has to be varied. And the merits of this yarn numbering system, especially the indirect system, that is the weight of the fabric can be calculated easily. The threads per inch are directly proportional to the square root of the yarn count, and so they can be easily calculated. The disadvantages of the indirect system would be because the size of the yarn cannot be given directly. The second one is, if there are two different types of yarns present, suppose it is a multi yarn, then in that case there is always a problem where we cannot calculate the count of this particular folded yarn. Now, the second method is the direct count method, and it is called the linear density method. So, the count of yarn, that is the number of weight units per one unit length. So, the length of the yarn is constant here, whereas the weight keeps varying. So, here higher the count, we can understand that the yarn will be coarser when it is higher. So, this is used mostly for synthetic fibers, for jute as well as for the silk. So, in the direct count here, the weight of the sample into unit length of the sample by unit weight of the sample into the length of the sample will give the correct count of the particular fiber. Here we have two more, the tex system, or we call it as a Lee system also, where the weight is in grams of 1000 meters of yarn, and we can also call it as a decitex or a kilotex, like the metric prefixes can be also used to denote the count of the yarn here. So, the tex count will be again weight into 1000 meters by 1 gram into the length of the yarn. And the other one is the denier system, where we have 9000 meters of yarn. So, instead of 1000 meters, here in the denier system 9000 meters are being used here. So, whereas we have another system called the pounds per spindle system for the jute, where 14,400 yards of yarn is weighed per 1 pound, then it would be a 1 count for that. So, similarly, the formula can be arrived replacing the previous or maybe the yards and the pounds. So, there are certain advantages of this direct system, where the count directly expresses the size of the yarn. So, the count of the folded yarn also can be easily calculated by this method. But the demerits here for this system is, it is difficult to calculate the weight of the fabric with the direct system. Now, we have seen about the count. Now, let us see about how we can measure the yarn count. For measuring the yarn count, the first thing is we should have the known length of the yarn, and the second one is we should have a very good balance of even a very accuracy of 0.001 milligrams. So, there are different methods or different machinery that is used for the count of the yarn. The first one is the warp reel balance, we also call it as a skein winder. So, on this particular skein winder, any type of yarn count can be calculated. So, here the balance is in such a way, the skein is wound around this, and the size or the diameter of this would vary from one fiber to the other. For cotton, it is 1 yard circumference, where we require to weigh around 120 yards to get the count, whereas for jute it is the circumference of the wheel would be 2.5 yards, and we require to have around 300 yards of the yarn to weigh the yarn. And here the first one is, a lee is prepared by winding it around the circumference, and then the lee is taken and then analyzed in analytical balance with 0.1 milligram accuracy, and then the weight is converted into the pounds. So, from that we can derive about the count using the formula which has already been discussed. And we have another system using a Beasley balance, especially if the yarn is not available and we need to arrive at a count of a yarn that is being used in a fabric, then we have to use the Beasley balance, where in this we have a template that is given, where on the template you can cut a fabric sample for the metric system, for the cotton, linen, woolen skein and the worsted count. So, each one has a different size of a sample that can be cut, and the fibers are raveled out from that. And in the Beasley balance, we can see that there is a very lightweight beam that is pivoted, and at one end of the beam we have a pointer that would be pointing onto a scale, and the other end will be a hook onto which we are supposed to put the yarn for the weighing. So, there is also a particular area wherein you can put a notch or a standard weight into that. So, when the standard weight put into that, and first it has to be leveled, and then a standard weight has to be put into the notch, and at that point you can see the pointer will be exactly opposite to the datum line on the scale. Now, at this point, after raveling out the yarns are placed one by one onto the hook. When the datum line again reaches its original position, then you have to count the number of yarns, and from that we have to calculate the count of the yarn. And we have yet another type of an instrument called the quadrant balance. This is, we can read the yarn count directly from it, and it has a provision where there are 3 different scales are present on it, where the top scale would give for the cloth weight directly in ounces per square yard, and there is a middle scale where you can use 8 yards length of the yarn for measuring the count, and the third scale would be for measuring the 40 yards of the yarn. So, it also has a cross beam where you have a hook on which you can weigh the fabric or maybe the yarn, and there is a pointer which would run on the scale, that is the 3 types of scales that are present. So, taking the yarn, the length that is sufficient for the measure is put onto the hook or the fabric, and then we can get the weight immediately because the reading is shown on the scale. Now, coming to yarn twist. Yarn twist, when we define it, it is a measure of spiral turns given to a yarn in order to hold the constituent fibers together. So, the twist has a role on different yarn characteristics, and the similar way it also has a role on the fabric characteristics as well. So, generally when there is lot of cohesion between the fibers, then we can see that the yarn twist takes place. So, this cohesion will lead to the strength, and so the twist will add or contribute to the strength of the yarn. So, it also defines about the appearance of the yarn, how serviceable the yarn would be, and how durable the yarn would be. So, generally the warp yarns, because they are on the loom on a stretched condition and under tension, always the warp yarns are given more twist compared to the weft yarns. And if the twist of the yarn is low, then we get a lofty yarn, that is where the yarn is slightly the resiliency of the yarn would be good enough, and that is more suitable for a knitting fabric, where it leads to softness and it has a lot of covering power and also leads to the warmth. And if suppose the yarn twist is very high, up to a certain level we can see the yarn twist, it leads to the strength in the yarn, but later on at a point we can see that the strength starts decreasing at the optimum point. So, in case the yarn twist is very hard, we can see that we get a very hard yarn, or the diameter of the yarn would become thinner, thereby the covering factor would come down, and sometimes there are some crinks that evolve out of this yarn, and it is most suitable for the crepe fabrics. So, we see that we can use a single yarn or a plied yarn or a cabled yarn. So, in single yarn the fibers are twisted together, in a ply yarn 2 yarns are twisted together, that is 2 singles are twisted together to get a ply yarn, and from ply yarn the different ply yarns can be twisted to get a cable yarn depending upon the usage and depending upon the end use of that. And in case of double yarns, 2 single yarns which have an identical twist will be twisted together in the direction which is opposite to the single yarns. Now, because when we see that there are different types of twists given, S type and Z type. So, here in case S type twist is given to both the yarns, then in case it is being plied, then Z type twist is given. So, this gives a very textured effects and different effects on the fabric later on. So, the amount of twist in a thread at each stage of manufacturing is given by a number, the numerical we call it as TPI, that is turns per inch, which will give the indication of how many turns are present in that particular yarn. Now, there are certain factors that would affect the twist. One is the count of the yarn that is to be spun. So, what is that we want a count for, whether it is for a knitting yarn or for a woven fabric. So, that has to be considered, and the quality of fiber or the cotton that we are going to use in spinning that yarn. And then we would like to know whether that yarn is to be used as a warp yarn or a weft yarn. So, even then there is a chance for the twist factor. And then how fine you want the yarn to be. So, that means if you want a finer yarn, the twist has to be higher, and if you want a softer fabric, then the twist has to be low. So, these are some of the factors on which the twist would depend, and there are also some directions of the twist which would affect the fabric. Now, if in the warp yarns we use alternatively S type yarns and Z type yarns in bands. So, what happens is we can see a stripe effect though it is made out of a single colored yarn. Because of using S type twist and Z type twist, we can see a subdued stripe effect on the fabric, and this is because of the light reflection that falls on these two sets of the yarns. And when yarns are twisted in the opposite direction, they give a very textural effects, and as I told you, sometimes in crepe yarns this effect is required, and such yarns are used in these crepe fabrics. Now, when we talk about the yarn twist, three basic parameters have to be considered. One is the twist direction, next is the twist level, and the third is the twist factor. So, as the twist direction, as I told you earlier, we have two directions, one is the Z direction and the S direction. So, that means when you hold a yarn upright position, when the twist follows the central part of the letter S, then we call that direction as a S twist. And same is the case if the central portion of the Z is relevant to the direction of the turns onto the yarn, then we call it as a Z twist. So, as we know, the turns per inch, as I told you earlier also, turns per inch is supposed to be the numerical value that is to be given. Now, the twist factor, we have another one where the twist multiplier, where it is the radius of the yarn that we consider at the different twist level. The twist character of the yarn is known without the knowledge of the yarn count also here. So, these three parameters are very important. In case if the yarn has a high twist factor, this will increase the tenacity and the yarn elongation, and because of the higher twist, the short fibers that are present in the staple yarn will be already into the turns, and so we can see that the short fibers are not visible much, and so it also improves the spinning ability, and when fabric is cut you can get a very clear cut fabric, and in fact it improves the resistance of the yarns. But if low twist factor is given to a fabric or a yarn, it gives a very soft handle fabric, but the yarns are bulkier, more hairiness is present on them, and they reduce the yarn's tendency to snarl, and the output with the same rotor speed will be, that is an increased output can be seen with the same rotor speed, because the number of turns are low. Now, how do we measure this yarn twist? We have a direct counting method where it is a very simple one, where we require to have a magnifying glass to understand about how we have to measure the twist. So, there is a small instrument that it can be used, where on the instrument we have two jaws, one is a movable one and one is another immovable one. So, the yarn is clamped onto the rotating jaw, and we have the immovable jaw, and then at the end of the yarn we have to have a standard weight to keep the yarn in a straight position. And generally when we are testing the yarn, we should see that we have to leave at least 1 meter from the edge of the yarn and then only start the measuring the twist of the yarn. So, the rotating jaw is connected to a counter wherein we can count the number of twists, and this we have both the motorized and we have the mechanical rotating clamps. So, after the yarn is put between these two jaws, and then we have to rotate the clamp either in the clockwise or anti-clockwise depending upon the type of twist that is present in the yarn, that is if it is Z or S twist. So, when the yarns open out, then we can put a needle in such a way that we start from the non-rotating clamp to the rotating clamp. We have to put the needle between these two yarns and then traverse it in such a way that when the needle is traversing, it should be very clear, indicating that the yarn twist has been removed from the yarn. So, the counter will give the number of twists that have been removed. So, that gives the number of twists per inch or whatever may be the distance between the two clamps. And generally to keep the yarn in a straight position, without adding tension, we use generally 0.5 centinewtons per tex weight at the end of the yarn. And sometimes a magnifying glass also can be used to understand if the amount of twist has been removed. And here there are specimen sizes that can be used for a single spun yarn. Generally 50 tests have to be made for single spun yarn, and for cotton the specimen length is 25 millimeters, whereas for woolen and worsted yarns the specimen length should be 50 millimeters. In case of folded yarns or cable yarns or continuous filament yarns, minimum of 20 tests have to be done and the specimen length has to be 250 millimeters. So, an average of these tests have to be recorded, and that will give you the yarn twist. And all the testing has to be done either to the yarn or any other type of material only after it is been conditioned under standard atmospheric conditions for 24 hours, and only then testing can be done. Now, there is yet another twist tester called the continuous twist tester, the one which I have discussed earlier, where it is not a continuous one. So, every time a yarn has to be cut and then placed between the jaws, and then it has to be verified. Now, in this continuous twist tester, it is much easier, where continuously the yarn can be measured about the twist at different intervals. So, in this the yarn from the package is directly passed through the guide to the clamp, where it is a mobile one, and the second one it would go to another clamp, the immovable one, and then it is wound on to the winding drum. So, similar to the previous machine, we also have here a knob to turn, and so the distance between these two has to be maintained. So, similarly the yarn has to be untwisted, and there is a magnifying glass in fact, wherein we can see whether the twist has been untwisted or not. So, this also can be easily done. So, once that part of the yarn has been untwisted, so that can be removed, that is the clamps can be loosened and the yarn can be removed, and then an extra length of yarn can be drawn from the package and it can also be measured. So, it is much easier to measure 20 times on the same package. Now, we have yet another one called the untwist twist method or the twist contraction method. This is based on the fact that when yarn twist is increased, the length of the yarn would decrease, and yarn twist is removed, then there is an increase in the length, and when every amount of twist is completely removed, it would reach the maximum length. So, first the original length of twist is inserted and the twist is first removed, and then later on slowly the twist is reintroduced, but in an opposite direction. Suppose the yarn has a S direction twist, now the yarn is given a Z direction twist after it is removed, and then it is done in such a way that the length would remain the same. So, between these two we can understand about, by untwisting and twisting it again or retwisting it again in an opposite direction, the TPI, either turns per inch, can be calculated from this method. And there is one more method called the tension type twist tester, where a little tension or weight is given to the yarn. So, it also has a pivoting point, and the yarn is clamped between the rotating jaw and the other jaw, and there is a pointer in fact at the pivoting point, and this pointer is first set to 0. That means, the yarn is clamped between these two jaws, and after clamping the yarn is pulled towards the rotating jaw, and then it is clamped in such a way that the pointer indicates a 0 mark on the scale. Now, there should be little tension or weight that is given here also to keep the yarn straight, and then after the twist is removed, either the Z or the S twist, by using the counters we can calculate that, and the knob for turning. So, once the twist is removed, then the pointer would move on the scale to a location to identify the amount of length that has been expanded, and then again when the twist is inserted, we can see that it has to come back to its 0 position. So, generally this is not an usual method that it can be used or not recommended for understanding about the actual twist of the yarn, but in case where we require some production controls, this is generally used, because what happens when the twist is removed is the unsupported yarn in that may slip one another and improving the length of the yarn. So, the reading on the scale would give the length of the yarn, and so for this purpose this is generally not recommended for identifying the twist. And then we have another method, the microscopic technique, which is very easy method, and generally the researchers generally go for this method because a very small portion of yarn can be tested at a time. Though it is a small one, but still it gives an accuracy measurement for the researchers. And here the microscope is equipped with a graduated rotatory sample stage, where the angle of the twist in the yarn and the diameter of the yarn can also be measured at the same time. Here first the circular rotary stage is set now to have a 0 mark coinciding with the index mark that is there on the microscope, and then it has to be fixed in that position. Then yarn is to be mounted on the slide and has to be placed on this rotary stage, and then it has to be clamped with some catches that is present on them. Now yarn has to be focused very clearly with the eyepiece, so that the cross wires on the eyepiece are parallel to the yarn axis. Then the catches are released, and now the stage is rotated until the cross wires is tangential to the helix of the yarn. Now the catches are once again put up, and the angle of the stage rotated is to be noted as a twist angle. The eyepiece is rotated so that the micrometer scale is perpendicular to the yarn axis, and we can read the width of the yarn from it. The yarn diameter, if suppose it is b inches and the yarn twist angle is theta, then the length of the yarn occupied by this would be pi d by tan theta. So, the next factor in the yarn is the yarn crimp. So, this generally happens, the warp yarns and the weft yarns, when they undergo the weaving process, they pass one over the other. So, in the interlacement process of these warp yarns and weft yarns, certain amount of waviness is imparted to the yarns, and that we call it as yarn crimp. So, this is referred to the amount of bending that is done by the thread as it interlaces with the other threads that are lying in the opposite direction of the fabric. So, if you take the yarn crimp definition, it is the ratio of difference of length of yarn taken from the length of the fabric to the length of the fabric, that is, after it is ravelled, what would be the length to the actual length of the fabric. Now, the factor of crimp affects many properties of the fabric, where it affects the cover of the fabric, the thickness of the fabric, the softness, the hand of the fabric. When it is not balanced well, then there are some problems that even an apparel or a garment would encounter, because in the wear the fabric would turn. That is, if the pants are longer enough, you can see actually there should be a balance in a garment when we wear. So, that would twist in case the crimp is not balanced in the yarn. So, when the crimp percentage is very high, then the resistance to abrasion will be higher, the shrinkage of the fabric will be lower, the softness of the fabric will be finer, and the stiffness of the fabric will be lower in case the crimp is high. Now, how do we measure this crimp? There is an instrument for measuring this crimp, where there is a horizontal scale on a base of 60 centimeters length up to 0.1 centimeters precision, which also has two grips. So, one is the pivoted grip, which has an extension with a tension weight ranging from 0 to 35 grams, and there is an index mark on the extreme end of the pivoted arm. So, between these two we have to put the fabric the yarn sample. Here the waviness is present in a fabric. So, first the 25 centimeters long sample has to be taken. For that, on the fabric we are supposed to mark two parallel lines, and then cut this parallel lines, and the sample is being taken out, and from that we have to ravel out the yarns, and care has to be exercised while raveling out and while you are placing into this instrument. So, the first the raveling is done in such a way that the central part of the yarn is first ravelled out with a needle very gently, and the end is put into the fixed clamp, and the other end is again gently taken out and put into a moving or the movable clamp. Now, after we know the count of the yarn, the standard weight is taken based on the count of the yarn, and that is put onto the weight counter, and now the second gripper, which is a movable gripper, is moved gently from the immovable gripper until the yarn is straight, and we can understand the length based on the scale reading that is already present on the yarn. So, the pulling off the second gripper has to be done in such a way that you should see that no extra tension is been given and no extra stretching has been done. So, in that case we can see that what is the length of the fabric is already known where we have taken the sample from, and now the extended length of the yarn is already noted by the scale that is present on the tester. So, here the crimp percentage would be the uncrimped length by crimped length by the crimped length into 100 gives the crimp percentage. So, this is how we can measure the crimp of the yarn. So, we have seen about how the yarn types are, what are the creation of different types of yarns using different types of machinery, what are the characteristics, how these yarn types or the twist or the crimp would affect the characteristics of the fabric, and what is the fineness of the yarn, how we can measure the fineness of the yarn, and the types of instruments that are used for measuring the fineness of the yarn, and about the yarn twist and how the yarn crimp and twist together would influence the fabric, and how we can measure to understand the interaction between these two, because all these factors in the yarn would be an interaction when the fabric is being made.